Hello, thank you for watching this video. So in this video, we're doing question 2 of November 2023 question paper mathematics paper 1. And these looks like we have arithmetic series and quadratic number patterns. So let's get started. 2.1. Given the arithmetic series, so we are given this series here, and we are told it's an arithmetic series. So let's go to 2.1.1. So you're just told that this is an arithmetic series, nothing much. They're saying, determine the value of T91. So they're saying, find T91. What is T91? So T91 is the 91st term of this series, right? So because it's arithmetic, so you have 7, you have 12, you have 17, plus it continues. So since it's arithmetic, you know the general term is Tn is equal to An, A plus n minus 1 times D. So to find T91, you need to know your A and you need to know your D. So your A is 7, which is the first term of the series, and your D is the difference between any two consecutive terms. So this is 5 and this is 5. So you know everything. So your Tn is equal to 7 plus n minus 1 times D, which is what? Which is 5. This is your Tn. Now, we want the value of the 91st term. So T91 is equal to 7 plus 91 minus 1 times 5. So the answer of this is T91. You can punch that in a calculator. I'll also do the same thing. So 7 plus 91 minus 1 times 5. So your answer is 457. 457. Which means T91 had that value. It's 457. So we move on to 2.1.2. What are they saying? They are saying calculate the sum of 91 terms. So they want S91. This is the sum of 91 terms. You know this is an arithmetic series. To find a sum for an arithmetic series, you say your Sn is equal to n over 2 into 2a plus n minus 1 times d, right? But now you want to sum for 91 terms. Put your 91, your 91. This is your A for your sequence, which is 7. This is D for your sequence. So sum of 91 terms is equal to 91 over 2 times 2 times the first term, which is 7, plus 91 minus what? Minus 1 times D, which is 5. So the answer of this will be the sum of 91 terms. You can punch that on a calculator as I do on mine. So you say 91 over 2 times 2 times 7 plus 91 minus 1 times 5. So you get that the sum of the first 91 terms is what? 21,112. This is the sum of the first 91 terms of this series. So let's move. We're going to 2.1.3. What are they saying? Calculate the value of n for which Tn is equal to 157. So we are told that Tn is equal to 517, right? So we're told that Tn is equal to 517. So they want the value of n for which the Tn will be 517, which means they're asking what is the position of 517 in your sequence, in your series. So in our series, what is the position of this? You want the value of n. So what do? You have your Tn is that. So Tn is equal to what? It's equal to 7 plus n minus 1 times d, which is 5. The Tn, which is this, is equal to what? 517, right? Then you solve for a value of n, which they are looking for. then the first thing, you transpose the 7 to the other side. So you have 5 to n minus 1 is equal to 517 minus 7, which is equal to what? 510, right? Then you divide by 5, by 5, by 5. You get that n minus 1 is equal to 510 divided by 5. Find that in a calculator. 510 divided by 5. Get that it's 102. Therefore, your n is equal to what? 103. So, the term 517 is the 103rd term on our series, which is this one. So, it occupies the 103rd position. We're done with 2.1.3. Now we move to 2.2. Let's go. So what I'll do, I'll clean the board, and then so that we start 2.2 on a new page. Looks like it will be a challenge on its own. Let me clean the board. Okay, so now we're doing 2.2, the quadratic number pattern. So let's go. 2.2 will read as follows. The following information is given about the quadratic number pattern. So you are given this information here. You are told that the first term T1 is equal to 3, right? And you are told that the difference between the second term and the first term is 9, which is term 1 minus term 2 minus term 1 is equal to 9. And you're also told the difference between term 3 and term 2 is 21, which is the difference between the second and third term is 21. So 2.1.1, sorry, 2.2.1, they are saying show that T5 is equal to this. They wanted to find the value of the fifth term. That's what they wanted to find. It's 2 marks. So what do you know? You know the first term, right? The first term is 3. And you know the difference between the first term and the second term is what? It's 9, right? So now, which means this minus this, it gives you 9. Which is, if you add 9 to this 3, you will get what the second term is. So 9 plus 3, that is 12. Let's go. Then, you are also told that the difference between the third and the second term is 21, which means you have what here? You have 21 here, right? So now, which means when you subtract this third term by the second term, you get 21. So if you want to know what the third term is, say your 21 plus that, right? Looks like it's 33. Right? So this is the third term. So this list continues. So you know that this is the common difference, this one here. It's common, which means it does not change. So this difference does not change. So you say your 12, your 21 minus 9. Your answer is 12, which is you have 12 here as well. Right, let's double check. 21 minus 9, that is 12. So now to get the term that is here, say 21 plus 12. So 21 plus 12, what do you get? You get 33, which is 33 here. So to get the next term, 33 plus 33 is 66. This is the fourth term. So you have 12 here, yeah? Add 12. 12 plus 33, what do you have? You have 45. To get the next term, which will be, this is first, this is second, this is third, this is fourth, this is fifth. So to get the fifth term, say you have 45 plus 66, what do you get? You get that your T5 is 111. Therefore, your T5 is equal to 1, 1, 1, 1. So you've answered their question. So you use this information that you are given. Done. We move to what? to 2.2.2. They are saying what? They are saying show that the general term Tn is equal to what? 6n squared minus 9n plus 6. This is what they wanted to show. They are saying show that the general term of this sequence is that. So, we know the general term is in the form an squared plus bn plus c, right? And your a is equal to twice, so you know that your a, which is this, 2 times a is equal to your common difference. Your common difference is what? Is 12. So which means you divide by 2. Then you get your a is equal to 6, which is what you have there. Then your Tn becomes what now? Take this Tn of 6 of yours and put it back there. You have 6n squared plus bn plus c. Your general term Tn is still incomplete. You need b and c. So you know what the first term is. First term is equal to 3. So you can say, okay, T1 is equal to 6 into 1 squared plus b into 1 plus c. So you know what T1 is. Your T1 is 3. So you say 3 is equal to 6 plus b plus c. Therefore, b plus c is equal to minus 3. If you transpose the 6 to the left-hand side, you have an equation here. Do the same thing for the second term. You know what the second term is? So okay, T2 is equal to what? Equal to 6 times 2 squared plus 2b plus c. You know what T2 is. Your T2 was what? It was 12, right? 12 is equal to what? It's equal to this, which is 6 times 4. This is 24 plus 2b plus c. Then transpose the 12 to the left-hand side. You get minus 12 is equal to 2b plus c. So you have two linear equations, this one and that one. You can solve them simultaneously using substitution or elimination. I like elimination better. So minus 12 equal to 2b plus c, and the other one is minus 3. It's equal to b plus c. Then we eliminate by subtracting. This negative 12 minus 3, get minus 9, is equal to 2b minus b, you get b, c minus c, get 0. Therefore, your b is equal to minus 9. Which is that? Which is this. So your Tn now looks like 6n squared minus 9n plus c. So you are missing a c, right? So you can either plug your first term here and find the value of c, which is what I'm going to do. Where's the first term? First term was 3, so you have 3 is equal to 6 minus 9 plus c. So this is 3 is equal to minus 3 plus c. So your c is equal to 6, which is that. Therefore, your Tn is equal to what? 6n squared, right? Minus 9n plus 6. This is your nth term. We found your nth term to be that. We have proved, we have shown them that that is the nth term. So we go to the next question, 2.3. So for this one, I'll clean the board again so that we have all the space that we might need. So we have found that Tn is equal to 6n squared, right? Minus 9n plus 6. This is what we have. So let's clean. So we go to 2.2.3. 2.2.3 reads as follows. Show that the pattern is increasing for all n is an element of natural numbers. So they wanted to show that your pattern is increasing for all n is a natural number. So what does it mean for a sequence to be increasing? So a sequence is increasing if a sequence Tn is increasing, right? If your n plus 1 above n implies that Tn plus 1 is greater than Tn. This is what it means for a sequence to be increasing. It means that if you take, okay, in simple terms, so in simple terms, what we're trying to say is a sequence is increasing if n plus 1 greater than n implies that Tn, the difference between two consecutive terms, is greater than 0. This is what it means for a sequence to be increasing, which means the difference between two consecutive terms is greater than 0. So now, if we want to show that our sequence is increasing, we must show that the difference between two consecutive terms is greater than 0. So let's do that. So we need to find, we know Tn is equal to what? 6n squared minus 9n plus 6. Then we need to find Tn plus 1. Tn plus 1 we find by 6 at n plus 1 all squared minus 9 at n plus 1 plus 6. Let's simplify this. If you simplify it, we get that we get 6 into n squared plus 2n plus 1 minus 9n minus 9 plus 6, right? So Tn plus 1 is equal to 6n squared, this times that, plus 12n, this time that, plus 6 minus 9n minus 9 plus 6, I think. So your Tn plus 1 is equal to, if you look at these, this and that are those terms that are there. So we can group these and say 6n squared minus 9n plus 6, right? So we've taken this, we've taken that. So what are we left with? We're left with what? Plus 12n, which is this, plus 6. This is what we're left with. Actually, not plus 6, and that minus 9, and minus 9, which is this one over. So it's these that we're left with. 12n plus this and that. So therefore, your Tn plus 1 is equal to what? Is equal to 6n squared minus 9n plus 6 plus 12n minus 3. This is what we're left with. Then now, we said that to show that this sequence is increasing, the difference between two consecutive terms must be positive, right? Should be greater than 0. Now we have to find the difference between Tn plus 1 and that, and see if it is positive. Then if it is positive, then our sequence is increasing. Let's go. So your Tn plus 1 minus Tn is equal to what? It's equal to this, which is 6n squared minus 9n plus 6, right? Plus 12n minus 3. Subtract. What are we subtracting? We're subtracting 6n squared minus 9n plus 6. Then this and that go away. So the Tn plus 1 minus Tn is equal to what? Equal to 12n minus 3. Is this greater than 0? Yes, but not very obvious to see. So you can say this is 12n minus 2 minus 1. This makes this minus 3. Then group these two Actually, not this way. This doesn't look very nice. You can say, okay, you have 9n plus 3n, which makes 12 minus 3. Then you have 9n plus 3 into n minus 1, right? I think we can all agree that, so this is your tn plus 1 minus tn. If you're looking at this, you can see that 9n is greater than 0 if n is a natural number, right? And n minus 1 is greater or equal to 0 for n is a natural number. So that means that you have tn, which is equal plus 1 minus tn, to be equal to what? 9n plus 3 into n minus 1, right? So we're saying that for all n is an element of natural numbers, right? This 9n is obviously greater than 0, and n minus 1 is greater or equal to 0. So you are summing something that is strictly positive and something that is at least non-negative, which is greater or equal to 0. Therefore, tn plus 1 minus tn, which is equal to these two things, 9n plus 3 into n minus 1, is greater than 0. Because you are summing something that is strictly positive and something that is strictly negative. So this thing should be positive. That's how I think of it. I hope it does make sense. Maybe it is an easy way of showing this, which is why maybe it's 3 marks. Otherwise, this is how I would have done it. So since the difference between two consecutive terms is positive, then this sequence is